when it comes to blockchains, not many people actually know about it. They just know the word Bitcoin or say Ethereum. More people know what Bitcoin. Well, actually, most people don't know what Bitcoin is. They just know the term Bitcoin. But there's so much technology, ledgers and stuff, or technology such as ledgers that kind of go a part of it, which gives it its value. I mean, we give it its value, like people. However, again, the technology that Bitcoin has, with it being digital properties, what gives it its value. We're not going to necessarily create Bitcoin, but what we're creating is a blockchain. And when it comes to creating a blockchain, it provides, it has security and trust. To give you an example, by creating, like when a company, or if a company can create their own blockchain, the company can design it along with specific security protocols tailored, to its needs to prevent, extremely common vulnerabilities. Like, I mean, obviously there's public blockchains or blockchains that could be, open source. You know what an open source means? It just basically means like it's something that you can like we can have the code publicly available for people to, use it for their own little projects and stuff, or if they want to update the security of a company and whatnot. The blockchain, a lot of these projects will be open source. We'll have our own little GitHub uh, for the nonprofit, so people could actually use it. But one thing that I think is really cool is that it provides advanced encryption methods, zero knowledge proofs, to basically protect say a company like a tech company or whatever company's user data and transactions. um, you can make it decentralized. Most companies or most people find the value within, like, say, Ethereum or Bitcoin valuable because it's decentralized. However, you have other little, I mean, not companies but nonprofits or whatever group it is, a decentralization. However, you have people like Solana, which it is centralized. It's mainly them that control it, for whatever reason. And then a really big purpose of having a blockchain is immutable audit trails. So to give you an example, when it comes to money, if you were to have $200 in your wallet and someone stole it, you're less likely to know who is it that stole it. When it comes to blockchain technology, maybe you don't know the specific person, but people are actually able to track where their money is. Like, say if it was taken or stolen. To give you an example, I don't know if you guys saw a few weeks ago, someone stole, or a group of people stole like $200 million worth of Bitcoin, but sleuths and people globally were able to find those 20-year-old idiots, and they were, I don't know if the guy was able to get their money back. The guy was able to get their money back, but they were able to find the culprits that did it, which was some 20-year-old kids, right? Um, so that's one thing that's really cool. You can't just lose $1 trillion. And then obviously there's smart contracts that are tied to blockchains, especially for automated security operation purposes, such as there's specific cyber threats that kind of go into that, or lockdown systems during a breach and automating compliance checks. Uh, Having a blockchain can actually streamline security operations and reduce a lot of human error since it's automated. Um, yeah, obviously, like, and there's also tokenization as a service, or tokenization of security services. Uh, what I mean by that is, to provide an example with that, we have Bitcoin as the token, and Bitcoin as the blockchain. That's like, Bitcoin is built on the Bitcoin blockchain. So, or BTC is built on Bitcoin, which is probably a better way of saying it. And now there's a lot of, obviously, like, cryptocurrencies and other stuff that that may have that or entail it, but everyone does something different. To give you an example, Bitcoin is digital property, and that's why it's valued at $80,000 per Bitcoin at this time. Ethereum is decentralized internet, so that's pretty much what that is. So today we're going to use JavaScript to build, a pretty simple. We're not going to make it extremely complicated, but we're going to build a blockchain using JavaScript. Let me rephrase that actually. You can't necessarily steal from a blockchain if that like you can't actually do it. Like that's how secure a blockchain is. It's just more like if they were to able to take so to provide I guess more of an example of what happened. The person provided their seed phrase from their wallet to those kids, those 20-year-old kids. They provided their own wallet, and that wallet had $200 million worth of Bitcoin on it, and they were able to take it solely because the guy basically gave their password, which is social engineering, is what cybersecurity peeps would call it. Yeah. So like when it comes to why a blockchain is secure, right? It's considered it's considered secure because it's decentralized. You know, there's no single point of failure is what I would say. There's a decentralized structure that ensures that no single point of failure, even if one or more nodes are attacked or go offline, the blockchain continues to function. To give you an example, a blockchain isn't just run off of one singular system. Um, Here's actually a really good example: is ran off of my computer, your computer, and multiple other computers that is running a node, right? So it's like having you would have to shut down every single computer and more, right? And then there's a cryptography, you know, part to this as well, with hash functions. Each block in the blockchain contains a hash, a unique fingerprint or signature of that data within it. With that being said, this also is like creating a cryptographic hash function, i.e., like a SHA 256. So if like even if a single bit of the data is altered, the hash will change anyway. Altering it or altering everyone on the network that something is wrong. I mean, I'm sorry, not altering, alerting everyone on the network that something is wrong. And then obviously, like blockchain transactions typically use asymmetric encryptions where users have public key and private key, which hopefully you keep that secret. The private key being the seed phrase, which that guy that lost the $230 million did not keep secret. So it's just it ensures that only the rightful owner can authorize these transactions. And then when it comes to transactions as well, there's a digital signature that ensures that digital signature is like a really long thing, like a really long numbers and letters and whatnot. And then now I will say when it comes to a lot of the mechanisms that a lot of blockchains have is different. To give you an example, originally Ethereum was on proof of work, which is where miners would use a miner would say like you I'm sure you guys know what like a Bitcoin miner is or a miner how they would use their computer to mine. So the computer is solving complex mathematical puzzles to add a new block to the blockchain, and they are rewarded like a small amount, or even some people a significant amount of Bitcoin. And then, or I'm sorry, Ethereum. We were talking about Ethereum. I mean, that goes for Bitcoin as well. And then Ethereum it actually upgraded to Ethereum 2.0 recently, like a few years back, which was proof of stake. That allows validators who are selected to create new blocks. And the minimum to stake was like, I think it's 32 Ethereum. But, one Ethereum is like $3,200 now. But I think they're trying to change it to where it's just one ETH. Um, so yeah, that's it. Any other questions? No, no questions at all, bruh. Who did that? Who did that? All right, that's what I thought. So are we gonna start? We're gonna start. All right, we're starting. Starting now. So we're gonna create a const crypto equals require. Wait, can you guys see my screen? Please tell me you can see my screen. Oh, thank God. I was gonna say not again, not again. And then whenever it comes to JavaScript, you have to close it with the semicolon, right? So now we're going to go to class block with the brackets, and then we're gonna kind of space that down. Constructor index data previous hash. No, maybe I did. I knew that. Maybe you didn't know that. Why would I not know that? Man, why isn't it like okay, con oh my god. Hold on, I remember. I remember. Uh construct chill. Okay, I got it. I got it. I think I have it. What the heck? I know it. Bro, that's it. Constructor. Yeah. Man. Anyway. Alright, previous hash. And then equals. Yeah, that's what I'm talking about. We're cooking. We're cooking. It's like that SpongeBob. We're having it. We're having it. And then we have to put this function. So this index equals index. And then this dot timestamp equals new data. Then okay, yeah, 2.2 ISO s and then string this dot data equals data semicolon this dot previous hash equals previous hash. So I don't know if you guys saw it, but sometimes you can kind of finish it, and all you have to do is press like tab. That's like a little secret thing, and then this dot hash equals this dot. I think I spelled that right. Don't quote me. Okay, I did. And then we're gonna close this with that. I feel like I'm missing a bracket somewhere. No. We just gotta wait a little bit. Or, you know what, we'll just close it because it's gonna bother me. I'm gonna put it right here. Boop. Yay! So it looks nice. And I spelled constructor right. Alright, so. Frank, was that you? Alright, so the block class is a simple representation of a blockchain block in JavaScript. To break this down, right? The constructor parameters, i.e., like the index, data, and previous hash. We'll go through index first. This is the position of the block in the blockchain, right? So, there's block number one, block number two, then data. The data represents the information or data that the block is storing. It could be any kind of data, like a transaction record, basically. And then you have previous hash. The previous hash stores the hash of the previous block, linking blocks together to form a chain. So I guess you could call it a blockchain. Sorry, I had to slap my knee. Man, it was funny. Okay. All right, and then we have the properties. This dot index that sets the block's position in the chain. The timestamp portion captures the exact time the block was created using the new date in the ISO string, ISO gang, which formats the date in a readable standardized format, the ISO 8601. The data, this dot data, the date that stores the actual data. And by data I mean like transactions. So whenever creating the block, the data is stored, or the transactions are stored. And then we have previous hash. So Frankie, what does the previous hash do? Man, it just stores the hash of the previous block. It's self-explanatory, providing integrity. Oh, yeah, I can hear it. Providing the integrity to the chain by linking the blocks. And then the hash part, it stores the result. Calculate the hash, which is the unique identifier, or I guess you could say like forensic fingerprint of the block's content. And then you have the hash calculator. Um, the calculator hash, it's like a method, pretty much, like calculating the unique hash of the block's contents based on the index, timestamp, data, and previous hash, which ensures that even a small change in the block data will produce a completely different hash. So that's that part right there. Oh my god, this is too much for me. Too much. What's so funny, huh? What? Why'd you do the laughter? It's so easy once you get it. After you know how long it took me to understand this? 9 years. I'm just kidding. It did not take me that long. That would be really bad. I would cry. Then Sha 256. I feel like I did that wrong. I think, or did I do it right? Yeah, I think I did it right actually. I just gotta add the other parts to it. It's not missing a space, so we gotta put a tab next under the create portion. Kunga Kinga. This dot. Man, shut up. Hey, you want to do this yourself? That's what I thought. Dot timestamp plus. Man. I'm trying to remember. Hold on, give me a second. I'll remember it. It's coming to me. I'm waiting. I'm waiting. Okay, this. So this dot timestamp plus JSON, which means it's gonna more than likely be saved in a JSON file. This data, and there should only be one bracket. Pretty sure it should only be one bracket. I think. Did I mess up? No, I didn't mess up. I'm okay. I'm good. I'm good. I'm good. All right. You want to do this yourself? he's like, he's like, I apologize for my outburst. All right, and then we're gonna close the bracket, bro. I feel like I'm missing something right here. I don't know what it like. I feel like I'm missing a bracket or something. But there's another. I don't know. Okay, I don't remember. It's gonna. I think it's okay right now. I think it's okay for now. I think. Uh. Oh, I know what it is. I know what it is. Okay, I forgot the previous Crap. No, I remember. So right here, where it says this dot data, there's another part I'm supposed to add. You know, if cybersecurity people learn stuff like this, they would be the most powerful people in the world. Just saying. and then you close it right. Crap. Then you close it right there. Yeah. It's like that one SpongeBob part was like, we're doing it, we're doing it. What's nice about this is you don't have to do a back end. So freaking cool, right? No back end. Just create this wonderful technology. Um okay, now. So what we created is quite a few functions actually, i.e. the calculate hash function, which is like designed to generate a unique hash for a block in a blockchain. Um, to break it down for you, man, I wish I could just turn on my camera and just break dance right now. But anyway, like hashing an algorithm, like this function uses like crypto.createHash, which initializes the SHA, the SHA slash 256 hashing algorithm, which is a secure and widely used hashing function that outputs a fixed 256-bit hash. And then you have the data for hash calculation. The dot update, right? That whole thing. The method is used to add data to the hash. In this case, the function concentrates. The function concentrates several pieces of information from block, including the this dot index, which represents the position in the chain, the timestamp, the time at which this block was created, and then the JSON stringify, which converts the data property, which is most likely the transaction information or maybe the block content, whatever the company wants, into JSON string format. This previous hash, the hash of the previous block, linking it to this one, creating the chain structure. And then the last part is hashing the data, which is after combining the block's properties into a single string, the dot digest hex portion that computes the SHA hash and returns it as a hexadecimal string, which this output is the unique hash of the block based on its contents. So yeah, that's that portion. Um, Now we're gonna continue to the class blockchain part. Hey, Frankie, are we bad boy? How I feel making 250,000 a year making this. Sorry, did I say that out loud? Equals new block 0 and then quotations. Oh, the Genesis block. My favorite. And then semicolon to close this. And then okay, right there. What was that? I don't think I will. Get latest. And then we have to get the latest block. Get latest block. So fun fact, when it comes to a lot of stuff like this, it's already somewhere on the internet, and all you gotta do is like copy it. That's what beginners do, or what some companies do, I will say. I feel like I'm missing something. I made the constructor. Yeah. And then oh yeah, the return. So return this dot chain equals new block 0. Oh wait, no wait. Return this dot chain is something else. I already did that part. You know this is live, right? Frankie Boo. Man, length. Like this is actually going in our course thing. No joke. And then we have to add block data closing that right there. So then const new block, new. The only reason I'm showing you guys this, right, is because this is something, again, in cybersecurity. I wouldn't say it's. I would highly recommend people do this, in their companies. Obviously, we do it for our nonprofit, not just for learning, but to also help, you know, future peoples create jobs in this field. That's like the main reason why I'm doing this. Dot hash. And then we're going to close right there. I hate it. I hate it! Yeah, we can just close it right there. And then we'll do is chain valid. Boop. Beep. Oh, wrong one. This part is confusing. Oh yeah, return. Return this dot chain dot every I, and then oh yeah, and then we have to make the I, since this equals, we have to put 3 of those, and then boop, and then pipelines. I'll be honest, I forget those pipelines even exist. Don't worry, I promise I'm going to explain all of this. Block dot calculate. I don't know. I think I can remove that one for now. Where's the and signs? There it is. And we're actually almost done. Like with the whole thing, I promise. Please don't be mad at me. Previous hash. Chain. I think it's, I minus 1 dot hash. And then we're going to close the bracket. Or not bracket, the parenthesis. Is it parenthesis? No, it's not parenthesis. It's like I don't remember what that little thing's called. All right, let's run it. Let's see what's going on with this, Run. Run and debug. All right, we're gonna clip that out. I don't think we should run it. Um hmm. We could just get that out of here for now. So anyway, as of now, actually no, we could keep this. We'll keep it for people to look at later, so then they'll know. All right. So we do have to change this. We have to reformat some things, but we're gonna have this as an open source thing, so people could fix it themselves. Or you could do what other companies do, right? You're gonna be very surprised, right? So no one will ever tell you this, but what people do these days, no joke. Am I missing the boop? Watch this. If ChatGPT fixed it. ChatGPT fixed it. ChatGPT just gave me the whole code and fixed it for me. Oh, right here. This timestamp equals. I don't know. I made it up. Nah, it's So the this dot timestamp, which is, if I can remember, it's going to be. Trying to check. It's gonna be under the class block part. Woo! Wee woo! All right. So we got all that done. Well, actually, we're gonna remove this part for now. So, all right, we're gonna add. Or actually, we're not gonna add anything for now. Um, for now, and I promise we're actually almost done. The constructor portion is a special function that runs when you create a new instance of the blockchain class. In this case, it initializes the blockchain with a single block called the genesis block, which is the starting point of every blockchain. Every blockchain has a genesis block. And the this.chain is an array that will hold all the blocks in the blockchain. The new block can create the first block, index 0, with the date genesis block and add it to the blockchain array, which is the this.chain. And then you have the block class, which likely requires an index, some data, and maybe the hash of the previous block to create a new block. And then, to get the latest block, that little portion of code, this method retrieves the last block in the blockchain, pretty much. And then the add block, we'll talk about the add block part. So the data part is any information you want to store in the blockchain, and then the new block, which can create new blocks. Then this chain length is used as the index of the new block, and then the data is stayed in the block, the stored in the block, right? So in summary of all of this that we just created, the blockchain class creates a simple chain of blocks starting with the genesis block. Each new block contains a reference to the previous block's hash, establishing, the chain, and then the get latest block and the add block methods enable us to add and access blocks in the chain. So that's what that part does, right? So now we're gonna add the last portion. After this portion, we are done. We're done. Dunzo. You got it? I'm sure you do. Which will be the return feature. False. And then we're gonna add some. We're gonna. Oh wait, actually, I forgot to add something, which is the if function right here. So. Wait. This is wrong. This is wrong. The is chain valid? Yeah, this is wrong. So remember, we actually did this ourselves. Now we have to fix it. It's okay. We'll just fix it really quickly. This is actually a lesson learned. The reason why I added ChatGPT in this is because ChatGPT can actually give you, it's right, but it's technically wrong, if that makes sense. So, yeah. Sometimes, ChatGPT won't give you all of the information in full, and it would just look weird. Bruh. And then we gotta have the constants. Const current block equals this dot chain. Then we're gonna add the I. Const previous block this dot chain. I minus 1. And then if there's not supposed to be a space there, you're gonna destroy your code doing that. Hash Oh wait, I don't have to add that one. Boop. Oh, yes I do. Turn false that. Boom. And then we have the return false, and then this is going to be return true actually, since we already have a false feature. Why is that squiggly? Unexpected token, a constructor method, blah 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 was expected. But there's no need to fix this. Like, this is fine. Bruh. I hate when it does that. Stop it! Bruh. There. Jeebus. Then, right there. I feel like I did something wrong here. I hate it. I hate it. And then now we're going to create the constant part, which is my blockchain equals new. And then this is about to suck. I could just copy and paste it, but we're going to go through the whole thing. One block, and then we're going to put the one new. Okay, data. And then we're going to... Why did you put data transfer? No. Not good. Okay. So then we're going to put the... Okay, ISO string. No. And then amount. So this is where I'm going to show you guys something funny or cool, or I guess you could call it lazy. Boop, boop. So we don't really need that one. And then, actually, instead of doing all that, I'm going to copy this. It was an easier way of doing that, but yeah. Put that, and then we're going to actually change this to a 2. This to a 10. I'll explain all this, I promise. Probably not. Dot log JSON dot string defy blockchain no 2. And this is the last bit right here. Blockchain. I'm sure he's fine somewhere. My chain invalid. Yeah. All right, we're done. Oh. We gotta close it. What do we close it with, Frankie? No? What? Why would I put an X right here? What have you been using this whole time? Hey, pay attention. Keys. Where's my keys so I can get you to... I don't have my keys with me. We put a semicolon. We put a semicolon. Yes. Did you... Wait, did you... No, there's no way you thought it was an X. You just guessed. It's not a squiggly. It's a period with a little comma at the bottom of it. Bruh. All right, we're just gonna quickly explain all this, right? So the is chain valid is a function, or an is chain, yeah, is chain valid is a function, which is used to validate a blockchain by checking if each block in the chain is correct. Um, and then basically the is chain valid with the little, not brackets, but the those things. It checks whether the blockchain represented in the this chain is valid by examining each block's hash and the connection to the previous block's hash. A valid blockchain should meet all of the conditions, which is each block should match the calculated hash, and each block's previous hash should match the hash of the preceding block. So it's like to explain all of it, the this chain every iterates through each block in the chain, and it checks every it checks whether like every block satisfies the condition within the function you provide. If all the blocks satisfy the condition, which is the every returns true, otherwise it will return false. That's what the true and the false portion is for. And then I want to explain the block and then the I. So the block is the current block being checked, and the I is the index of the block in the chain. And then the I, which is the three equal signs with the zero and the pipelines. So this checks if the current block is the first block, and then the first block, which is the genesis block, is usually considered valid by default, so we can skip further in validation for it. For all the other blocks, which is the I and then the exclamation point, it performs additional checks. The block.hash and the calculation hash and all that jazz, all that stuff, it verifies that the hash stored in the block matches the hash calculated from the block's contents. And then you have the block.previous hash, which, this chain, the I minus one hash, ensures the current block's previous hash. So in summary, the function returns true if every block except the genesis block is valid. And then a valid block is one where, its stored hash matches the calculated hash. So it hasn't tampered, like it hasn't been messed with, pretty much. And then if any block fails these checks, the function returns false, indicating the blockchain is invalid. All right, so now we're going to explain the last part, which is setting up the blockchain. The const my blockchain equals the new blockchain, which is like my blockchain represents a new blockchain in this simplified. The chain, which is a property, and then the add block, which is a method, and the chain invalid, which checks the integrity of the blockchain to make sure blocks are in the correct order and have not been messed with. The my blockchain, or the dot add block, which is the amount 4, and then the add block, which is the amount 10. In a blockchain, each block contains data that represents a transaction or event, which means like two blocks are added with transaction amounts of 4 and 10 respectively. The add block method likely creates a new block, or it creates new blocks and links them in the chain by setting a previous hash reference to the previous hash, ensuring the chain is continuous. You can view the blockchain using a JSON format, or JSON file. So you can print it pretty much. What I mean by print is like there's a specific way you could check it, in Google Chrome pretty much. And then the console.log is blockchain invalid. Or I'm sorry, yeah, is blockchain right here, this last portion. This part checks the entire chain's integrity. It verifies if each block is properly linked to the previous one by comparing hashes. If any block's data or hash is altered, the chain would be considered invalid. Blocks are added with transaction data of the amount of 4 and 10, and then you can, of course, print it on the JSON file. The code creates a simple blockchain, adds blocks with transaction data, and checks if the blockchain data is valid. To give you an example, the constant or const my blockchain equals new blockchain creates a new blockchain instance. My blockchain dot the add block amount 4 adds a block with a transaction data showing an amount of 4, and then my blockchain dot add block amount of 10 adds another block with the transaction data showing an amount of 10. Console.log JSON stringify, the null2 prints the blockchain data as a structured JSON object for easy reading. Console log is blockchain valid, my blockchain is invalid. Checks if the blockchain is valid, untampered, and prints the result. In short, the code builds a blockchain, adds data to it, and checks if the data is consistent and untampered. That's it. No more.